Well, this is James, and I'm here today to talk about my project. So my project is a game adapted from Neuroshima, which is a board game slash video game on iOS. So let's first take a look at how it is right now. So because the project is really long and complex, I do not have enough time to actually finish the GUI, so it's only a half GUI, half message thingy. So as you can see, it says welcome player 1, please choose a faction, and so I will choose the faction here. And player 2 would be the same thing. And then they would place their base, and then they would start playing essentially. Let's say the yellow player wanna play that card onto the tile, so he would pick its orientation and then click on the tile, and as you can see, the card is already on the tile. And now the yellow player wants to end his turn, and so he would just click end turn, and now it's the red player's turn. So so how does the game end? So essentially, if the health of the base falls from 20 to 0, the game ends. If one of the players runs out of the hand, which there are 35 cards, and so they will draw cards, and if they run out of cards, the game also ends, and the player with the base that has the most health wins. So now let's take a look at how it is implemented. The first string to class, this is just a function that takes in a string and converts it to a class type. It's really, or an instance type. It is really useful in my program because I need to constantly convert the card index to the actual instance so that I can retrieve its attributes. It's adapted from the internet, and I don't really know how it works, but I guess it's fine. So next, mutate tuple. It's just a little thingy that I use to change the tuples in the attributes of the instances. I just use it because tuples are not mutable in Python, and if I did not do that, I would have to write the 4 lines every single time I want to mutate a tuple. And class center, this is just a little class that I use to split the program, split all of the images. What it does is that it converts the class instances, which are essentially just XC, YC, which defines the coordinates of the center, to the actual coordinates of the leftmost side of the rectangle. So if I do self.x and self.y and split the image onto that coordinate, I can actually have that hex aligned perfectly onto where I would want it to be. If I split it onto anywhere else, it would just get really messed up. So center is really just a helper class, and it's not really important. And now let's take a look at a card class, which is the most important class of my program. It's just all 140 cards from Neuroshima with some slight modifications. I will skip all of the details here, but you can see there are a lot of attributes such as attacks from all 6 orientations and their abilities, initiatives, and etc. Now display info. Display info is just a function that that gives you all of the information of that particular card. It's class method, and then the file path test. It's in my Readme file. It just tests whether all 140 cards has its picture files loaded correctly. So if I accidentally mess up with the file name or the file path here, it will actually give me an error message saying that you cannot load that, Pygame cannot load that file. But if I did everything correctly, it would just give me an information saying that oh, there is no error. And then the second class method, the restore mobility method. So what it does is that it takes all of the tiles on the board, all of the cards on the board, and restores their mobility. So there are some cards that can move each turn, and each movement would consume 1 mobility. And if they use up mobility, they cannot move on this turn anymore, but they can still move on the next turn. So what this method does is just to restore all of the mobilities at the end of each turn so that they can move again. Now rotate, it's also in the Readme file. It just rotates the card and displays the new attribute and stores that into that instance. Damage, deals damage, pretty straightforward. It reduces HP, or in this case toughness, of all of the cards that are affected. Add mobility, there are certain modules that can add mobility to the cards, and this is just a method that's used to reflect that. Add attack power melee, it just adds melee attack power strength. Reduce attack power melee, reduces melee attack power strength, and so on and so on, arranged. Initiative -1, initiative +1, these deals with the initiatives, which is one of the complex features of the Neuroshima rules, which I will briefly talk about later. Initiative add extra, reverse, and initiative add extra. These adds in 1 more initiative. Adjacent bonus gain, adjacent bonus reverse. So what they do is that they either add adjacent bonus to a tile or reverses the effect. So what happens is that in Neuroshima Hex, if a card is adjacent to its own base, it will actually get a nice bonus, being have +1 melee attack power, or have +1 ranged attack power, or 1 more initiative, etc. So what it does is just to reflect that the adjacency bonus is added or it's actually removed. So starting from here, it's all of the modules or instant action cards with functions. So you can see if, say, a player plays a medic card, it would actually just do one thing, self damage -1. I actually coded the self.damage method so that if you takes -1 as input, it actually adds 1 toughness. So this is essentially what it does. Quartermaster it's also the same thing, but here it's just a combination of the two. It adds 1 extra initiative and adds 1 initiative. So what I had in mind here is that I would first define all of the basic methods or functions, and then all of the modules would be a combination of one or some of all of these effects. And after effect, I have events. So, oh, that's actually later, so I will skip that. Here it's find adjacent. It's one of the helper functions that takes in a tile ID from 0 to 18 and returns a list of all of the tiles that are adjacent to the tile with that tile ID. So 0 at the center would have adjacent tiles of 1, 2, 3, 4, 5, and 6. And if you have a tile on the edge, it would actually have fewer adjacent tiles. So in this case, I can either not include all of these non-existent tiles, or I could put n-1 in there as a placeholder so that other programs can actually know that, oh, at that orientation there is no adjacent tiles. So that's why I have find adjacent / keep orientation, which keeps -1 in list as orientation indicator. It is unfortunately not used because it's not needed, but when I was programming it, I did not know that, so I included that anyways. So now let's take a look at events. So events are essentially just an extension of effects. So when you play a card, say transport, it would actually just execute the single event called event/transport, in which it would get your mouse position and clicks and everything, and if every single condition is met, it would execute the other function, which is tile.effect/transport. Oh wait, that's typo here. Anyways, yeah. So when you play a card, it would execute an event with a similar name to it: Saboteur, Transport, Medic, Officer, Sculptor, etc. and etc. So these are the event functions. And the reason I have all of these event functions is that it makes my life easier when I was actually programming the main loop. So here it's event/move tile. It's the function that moves a tile from its original position to another position. And here there is event rotate, where it actually rotates the card, and event move card, it moves card, which uses the base function and adds some other conditions. And move dodge is another type of movement that's only usable when the card is adjacent to an enemy card. Sniper, grenade, airstrike. Oh, here we are. So this function event play card, what it does is that it takes in the card that's being played, which is passed down by the main loop, and it will actually examine which card it is and apply appropriate actions. So if the card is an army, it would ask you where you want to place it, and after you confirm it, it would actually get placed on board and get registered on board. And if it adds an event or modification to a card, it also asks you where you want the modification to take effect and modify all the cards that are affected. And there's also battle, which is where a battle instant action card is played and all of the tiles go into battle, which I will cover later. So these are all of the individual card instances. There are 140 of them. There's really no other way of doing so other than maybe creating a CSV file and import that CSV file, but I figure it's about the same amount of work, and it's just that it's a little bit fancier, but as for the time and effort needed, it's still the same amount of work. So here it is. And as you can see here, it's just the center of all of the standard class instances. So here is the screen and the caption. So if you were paying attention, you can see that the actual game interface is 1280 in width and 720 height, and the caption is actually saying Neuroshima Text Project. And these are just the individual elements that I imported onto the main screen. So as you may have noticed, so let's take a look. You have the board, you have discard, you have hand, end turn, yes, no, pick, the options, and quit. And originally I also want to display the messages here, and maybe some other information here, but it's too time consuming and I do not have enough time to finish that. Alright, let's take a look at other stuff. So board list. What is board list? So board list is just a list containing all of the cards on the board. So here you can see the default value is all -1s. So a -1 indicates that the tile is unoccupied, meaning that there is no card on the corresponding tile. And if, say, the sender is occupied by another card of index, say 23, the board list 0, which is the first position, would actually become 23. So it's actually used by other functions and methods to make changes and update the board and etc. So Tilepedia. Tilepedia is just a dictionary that I defined that contains all of the information about orientation and adjacency. The details are not that important. It's just good to know that using Tilepedia, and by using Tilepedia and doing some operations like or I should say from doing some calculations from the Tilepedia, I can actually know which tile is adjacent to which and which orientation and relationship they are, which is really nice. And hit points is another dictionary that registers the health of the headquarters of player 1 and player 2. So as I said, the game ends if one of the player's headquarters is killed. And so if the health falls to 0 or falls below 0, the game loop actually ends. So I use hit points dictionary to keep track of that. And this is just a screenlet of all of these elements shown on the screen. The left and these are the same. Pygame display update. So after all of the initiation and all of the defining, here is the first update. So this is actually redundant. As you can see here, initialization ends, and here is one of the most important functions of this project, which is also included in the Readme file. Mouse interact position. What it does is that it takes in a tuple of the location of the mouse. Say the mouse is here, it will be 0, 0. If the mouse is here, it will be something, maybe like 1,400 or something. And it will actually take in that tuple and see what is below that. So if we take a look, so if the program receives a click here, it would actually interpret that tuple into the message pick 0, because in this case it's the user is clicking pick and it's picking pick 0, the first position. And if they click here, it will be pick 3, and if they click here, it will be discard 2, and if they click on the tile, it will be the tile ID, which I think it's a great time to actually give you guys some idea of how I define the tile ID. So I define it as follows. This is 0. Oh, oops. This is 1, 2, 3, 4, 5, 6, and the other layers are sent from 18. Alright, let's kill it. So this is mouse interact. It takes in a tuple representing the mouse position, and it actually gives you the information which can be processed to make other actions. Whether netted, this is just a function that determines whether a card on the tile is netted. So there is a unique net mechanism in Neuroshima hex. If a tile or card is netted, it cannot move, it cannot attack. So this is just there to actually check if it's netted. Because if it's netted, I cannot allow it to move, and I cannot allow it to attack during the battle phase. Clear dead. This is just after the battle, there might be tiles whose toughness or HP falls below 0, in which case they would be considered dead and there's no point keeping them anymore, and I need to visually update that. Update view, it just updates a card with its index onto the board tile using the board tile ID. Update board, it just updates the board, pretty straightforward. Adjacency bonus update, it updates the adjacency bonus. And global, it just updates the whole board, because in this case it only updates one of the tiles. Now it's battle. So what battle does is that it allows the current board, all of the armies on the current board, to battle each other using a specific rule containing like initiatives, attack powers, whether they're netted or and some other more complicated rules. I feel that it's really the best if you could actually check Neuroshima hex rules yourself by checking manuals that's available on the internet. So this is a move. It just moves the tile from its original position to its final position. And like I said, it does not check if the other tile is already taken. So if you would experimentally move a card to a tile that is actually occupied, it would actually delete that occupied card, which is a really bad thing to happen. That's why in my main loop there are other programs to make sure that this does not happen. So here are some other variables that are global. So there is current player, which defines whose turn it is. It is 0 here because the game hasn't started yet. Once it started, it would either be 1 or 2. And player 1, player 2, they just define the faction ID, which is 0, 1, 2, and 3. And once they pick their factions, it will be updated. A deck. So deck 1 and 2 defines the order of 35 tiles. So you could imagine you're holding a set of poker cards, and you would actually shuffle them at the beginning of each game so that you would not get the same result every single time. So this is essentially what it does. Once it's shuffled, the decks are passed to deck 1 and deck 2 and are stored throughout the game. And hand 1 and hand 2 are the list of the cards that the player is currently holding. They can actually play them or discard them. And when they are drawing cards, because in each turn they would draw enough cards so that they have 3 cards on their hand, it's also dependent on the number of cards on their hand. So rotate crop, it's also in my Readme file. It just crops an image that's just been rotated so that it will take the same amount of area as the original ones, so that I can keep rotating them without worrying about them flying everywhere. Because once you rotate it 60 degrees, it would actually make the actual image bigger, because all of the images have to be rectangles. Choose faction, it just asks the players to choose factions. Deck shuffle, like I said, it shuffles the deck. And starting location, it asks the players to pick locations, or the locations of their headquarters. Let hand, it's a function that updates their hand, because if it's player 1's turn, they would actually have to see all of their hands, all 3 or 2 of their hands. But when his turn is ended and it's player 2's turn, she would also need to see what kind of cards she is holding. So it's really reasonable to let that information onto the screen. And draw, it draws the hands. These actually work together to update that. Discard. So in Neuroshima Hex, like I said, at the beginning of each turn, the player draws cards so that he or she holds 3 cards in hand, but they need to discard at least 1 card. So what discard does is that it just asks the player to discard 1 hand, or like 1 card in their hand, so that the game can be passed to the next stage, which is the actual the playing stage. And there is health check. It just checks whether the headquarters of one of the players falls to 0 or below 0, and once that is true, health check would actually return true, and the game would end. For board, if the board is full, there would be a battle in place. So if all 19 tiles are taken, there would be a battle, so that in hope that it would clear some tiles up. It's also one of the original Neuroshima hex rules. So here, finally, we're at the main loop. It's still really long. So first, it prints, hello, you cannot quit before initialization is done. It's just because the way I program it, I don't really put any kind of event checks here, like before the actual running loop. Or to be more precise, in all of these individual events, they do check for the Pygame events, but they do not include Pygame.quit event, so that's why you cannot really kill the program just by clicking X or quit. So if you have not chosen all of the factions and everything, when you click X, there is really nothing happening. But if you did everything and you click quit, it would actually quit mostly. So here, deck empty hand. What does deck empty hand do? So because each time, at the beginning of each turn, the player draws cards so that he or she gets 3 cards on the hand. But when they are running out of cards, because there are only 35 cards for each faction, the original rule states that if a player is running out of cards, the other player can play one more turn, and then there will be a final battle. So that's what deck empty end does. It just checks that condition, and if that condition is met, the other player gets to play one more turn, and then it's end game. Alright, so here the real main loop. So while running, it updates the hand, draws cards, and asks the player to discard the hand, and tells the player it's his or her turn. And then it's a list of events. So during the game, let's say here, during the game, if you click here, nothing would happen. If you click here, you will quit the program. If you click on the board, for now, nothing would happen because all of the tiles cannot move. But if they can move, as you will see later, there can be a movement event. So here, the only real things that you can do is to end turn, or you can click discard, which will trigger the discard event, where you can either choose yes, in which case the card will be discarded, or no, where it will actually turn to the face. So player 2 is your turn again. I press discard, I press this, boom, the card is gone. And what if I want to play the card? I play the card, I pick its orientation, and then click the board, and voila, there it is. So end turn. Unfortunately, I picked 2 factions that cannot really move. I'll try it again. This time I'll pick faction that can move. And turn, and turn, and turn. show you guys how the card can move. But it seems that I don't have a good luck here. Alright, so let's take a look at the movement. These are not like actual movements based on their own mobility, but it's still a really nice thing to show. So if you click move and you click that tile, and first it asks you about the orientation, and you will pick one and you will move to an adjacent tile. Okay, back to the program. As I said, so it just gets a list of events, and if you left clicked and turn the turn will end, if you left clicked a hand or like a card on your hand, an event would be executed where you would choose where to play the card. And if you left click a card on the tile, it will actually display the information. I'll show you guys. So let's say you left clicked here, it will actually display all of the relevant information, like its name, its category, 0 because it's a card that has health and can move around and stuff, and image path, attack, armor, net, etc., etc. Let's do this. So this is events, and so this event button equals 3 is the Pygame code for a right click on the mouse just happened. As you can see, I really am using the mouse message, which comes from the original function that are defined. So mouse interact, parenthesis, a tuple of the position, etc., etc. Here you can see card restore mobility, and here is between turns. So from here, the turn of the first player ends, and the turn of the second player has not started yet. So what it does is that first it checks if the board were full. If the board were full, a battle would be in place, and that has the highest priority. So as you can see, it's here. And here it checks if the deck empty hand, which, if you remember, it's the variable that tells the program whether one player is running out of cards. And if that condition is met, then the program would do a final battle and check the health and display the health and tell you which one is the winner. Or alternatively, if this condition is not met, it will actually do a regular health check and then check if the health of one of the headquarters falls below 0, in which case, if it did happen, running is false, and the program would end really quickly. But if the condition is false, then running would still be true and the program would go on. So here it just checks if the player 1 does not have anything in his or her deck, and if that's the case, deck empty hand is changed to true. So this actually goes after the check because according to the original Neuroshima hex rule, after the deck empty hand event happens, the other player actually has one more turn to play and strategize like all of the tiles and stuff. That's why it goes after the condition check. And here is the same thing, except this time it's current player 2. It's largely a repetition of the previous one. And I'm doing that because I really cannot find any way to, or like a better way to program this stuff other than just copy paste it and add every single thing that should be different. So it's essentially the same as the first one. You can see here, like for each condition check, it not only does it check if it's the turn of the current player, it also checks if it's running. This is because if, say, player 1 clicks quit here, the running becomes false. If that condition is not checked, the program would actually run to here, and because running is not checked, it will actually goes into that loop. So my turn is true, and it just runs into the while loop. And because there is no quit event in the while loop, the program will not actually exit, which isn't a great thing to happen. That's why in each of the cases I check if it's running and running here. And again, after the player 2's turn ends, it actually restores mobility and checks these conditions, and here updates the number of hands, and then the program would go back onto the while loop and check if it was still running. So if it wasn't running, then fine, it will actually exit the main loop. But let's say here the player clicks quit, so running is false. Because I check running here, running would not, like this whole portion would not run at all, and it will actually just go down and go back and check the running again, and wow, running is false, so it will jump out of this whole loop, and then it just goes to the end of main loop and Python.quit. So what you're left with is just the Python shell that displays all of the information. So what other stuff I want to say? Well, first of all, this is a really long and complex program. That's why it's a little bit disorganized. As you can see, it's about 2K lines. There are a lot of copy pasting, but still it's a lot of work. I did not have enough time to get everything onto the message board that I actually designed. So yeah, which is unfortunate, but it is still like a playable game because everything is displayed here. Other than that, oh yeah, the style. You can see I did commented like, well, I commented some parts of the functions in the program, but that's just, to be frank, that's just for my own convenience, so that when I go back the other day or the other week, I will not like get confused of what the syntax is and what kind of input I should offer to all of these functions. So that's why it could look a little bit disorganized. I do apologize for that. But again, it's because it's a really long and tedious project. Well, let's just take a look at one of the gameplays in the end. Hopefully there wouldn't be any bugs. I do this and turn this card here, right here, I'm going to move it here and turn, I will discard this card, I will play it here, I will discard this card, and I'm under attack, so I'm gonna move my tile away from all of the enemies. I will move it here, and I will play the card here. I will pick, and whoops, I did it wrong, so I want to move it. So I click it, pick an orientation, and I move it. And because it only has one mobility, I cannot move it anymore. Alright, and turn, what just happened? Oh, the mobility check. There might be a little bug here. I would get into that, although it's like task lead. I already submitted file, so this time I want to have some toughness. I will just do that. Oh, it only works for one tile. Yes. Alright. And I will do that. And turn. And let's take a look at battle, shall we? Battle. Yes or no. Yes to proceed. Hold on. It's updated. And let's say I'm curious how many health is left for each headquarter. So I would discard my hand first and click. I would see that it has 18 HP left, and if I go to blue, it has 19 HP left. So let's just fast forward it. I will just discard all of the hands so that I can go to the end game, and you can see what's like in the end game. So yeah, if one of the player runs out of cards, no matter how many cards the other player has, he or she cannot play it. Or, like, more precisely, he or she has one more turn to play 3 of them, and then, or 2 of them, and then there's no way he or she could play it anymore because the game ends. That's what the rule is. And as you can see here, I only drafted 2 cards. That's because there are only 2 cards in my deck left. So you would see a final battle soon. So here, as you can see, it's a final battle, and the game just quits. I could let the game like sleep for maybe 500 milliseconds, but I didn't in this case. You can see the player 1 has 16 health left, the player 2 has 19, and player 2 is the blue one, and player 2 wins. Alright, I hope this video clears some things up and you enjoy it. And well, I kind of enjoyed coding this project, although it's really long and hard and tedious. But yeah, have a great semester.